So one of the last sections for radicals is going to be dealing with variables. So what we mean by a variable is a letter. But before we get into that, let's look at a few examples that lead us into that. So let's look at the square root of 9. The square root of 9 is a perfect square. We know that's 3. What's another way we can write 9? We can write it as 3 times 3. So this is still the square root of 9, and that's equal to 3. Another way we can write this is the square root of 3 squared. Because 3 times 3 is equal to 9. So the square root of this is still 3. But hey, notice, we have a 3 underneath the radical and a 3 right here. So it appears that when we have this radical sign and a square, we can just simply cancel them out and just be left with the number. So let's do a few examples to illustrate this. Let's take the square root of 4 squared. You see the square root and you see the square. They can just cancel out, so this equals 4. Let's take the square root of 16 squared. You see the square root, you see the square, those are going to cancel out, so you're just left with 16. Let's try a really hard one. Let's try the square root of 124,210. Big number. Square it. So we have the square root of 124,210 squared. What's the answer? Well, the square root cancels out this little square right there, so it just equals the number underneath the radical. 124,210. There's our answer. So what are we doing? We're just looking for that square, and then when we see the radical sign by it, we're canceling it out, so it just happens to be the number underneath. That's all we're doing. So if we have the square root of x squared, that means we're going to just simply allow it to be x. And notice, we can do this with different letters. I'm going to erase this now just so we have some more space. I could say that the square root of y squared equals y, the square root of n squared equals n, or any other number. Let's look at this example. The square root of y squared, x squared. So the y squared and the x squared are both underneath the radical. One way you could look at this is to split it up into their own radical symbols. Put them underneath their own houses. So you have the square root of y squared times the square root of x squared. Now you can look. Hey, we have a square root and a square. That means we can cancel them. So this is just y. Hey, look, we have a square root and an x squared. We can just cancel the square and the square root, so it just becomes x. So the square root of y squared times x squared is simply yx. Simple as that. We can even put numbers in there too. So let's say we have the square root of 64x squared. Well, break it up. We have the square root of 64. We have the square root of x squared. Square root of 64, that's 8. That's a perfect square. We know that that's 8. And the square root of x squared. The radical and the square root, the radical and the square cancel out, so you just have x. So the square root of 64 x squared is simply 8x. Let's do another one that's a bit more challenging. Let's try the square root of 40 y squared. So let's break it up into the radicals, into their own houses. So square root of 40, square root of y squared. What's the square root of 40? If we look on our perfect square list, 40 is not on there. So it looks like we have to do it the old-fashioned way. So what I'm going to do, what multiplies by what to equal 40? How about 4 and 10? So I'm going to write square root of 4 times 10. And then this y squared, square root of y squared, I'm just going to bring that down. I didn't touch it, so I'm just going to bring it down. Now, we can break up the 4 and 10 underneath their own radicals. So square root of 4, square root of 10. Again, I didn't touch the y squared, so I leave it. And now, I can start simplifying. The square root of 4, we know that's 2. It's a perfect square. So the square root of 4 went to be a 2. And hey, look, There's a square root and a y squared. That means the radical cancels out the square, so we're just left with y. Now what about the square root of 10? We could break that down if we wanted to into 5 times 2. But looking at this, that doesn't really help us because there's not going to be a square root of 5 or a square root of 2 to make a pair. So we would just end up putting it back together. So instead of writing square root of 5 times 2, I'm just going to erase that. And I'm just going to bring down the 10, the square root of 10. So our answer, 2 square root of 10 times y. But I don't like seeing that y in the background because I'm afraid that maybe you extended this too far, your radical sign, and it may look like the y is underneath it. So what I want you to do instead is to move the y around to the front. So that means it's going to equal 2y square root of 10. Okay? Now we're going to get into some more complex stuff. We're not going to be dealing with squares anymore. We're going to deal with